Welcome back to this third episode of building Micro Flash Delta, my 3-pound combat robot, and I got a bit of a change of plans for this particular episode. If you look back at my list of what I was going to do for Micro Flash Delta, one thing that was not on here was change the size of the robot. Now, as I mentioned last time at the end of the episode, it turns out that a lot of competitions for beetle weights have certain size limits, basically either 14 inches cubed or 12 inches cubed, things like that. So unfortunately, I'm not going to be able to compete in the event coming up here in August because Micro Flash Delta, as it currently stands, is 15.5 inches long. So what I'm going to do is I figured, well, at first though my thought would be, well, let's just knock them down to 14 inches and run like that. But that just means I'm doing a small modification to the back a little bit, trying to cram some things in, and then eventually, over the winter, I would knock them down to being a 12-inch cube. But you know what? Since I'm not competing in August anymore, and the next event is going to be the Motor City Massacre 4 in November, I'm just going to go ahead right now and modify the robot to fit into a 12-inch cube. So what's that going to mean is that, so move all this in a little bit, move the weapon a little bit closer to the weapon motor. I'm going to have to shift out the drive motors a little bit because right now they're a little bit too close together compared to the width of the weapon motor. So if I shift them out maybe a half an inch, 3/4 of an inch, that will allow me to push the drive motor in here and therefore reduce the overall size of this thing and hopefully get it all down to a 12-inch cube. Hopefully. So I got this little guy right here as a possible additional action later on. I found some 4mm bearings. So let me hold this guy up to the camera. This is an RC car bearing. In particular, it is from Traxxas. It's product number 5124. I got these from the local RC car shop. And these bearings fit great on the motor shafts of the typical motors that I run that are also the size of motors that a lot of Beetle Weight robots use. So I'm going to try to build into the side of the robot a bearing mount. Therefore, the side armor of the robot can take some of the load of any kind of vertical shock to the drive motors. Let's jump over to Blender and get working. Of course, what I need at this point is to actually put in a block representing a 12-inch cube. So I'm going to do that right now. I'm just going to have a plane at the moment. And let's do some math here. So bring up the calculator. 12 inches times 25.4, which of course that's 304 millimeters. I am actually going to try to shoot for 11.75. That way if I go over by a tiny bit, it's not the end of the world. So I'm going to say 298 millimeters on either direction for this cube. 298, 298. And this will let me know, well, this is exactly how much space I have to work with. So I still have the hope for trying to get a 4S battery in this thing. I just measured my battery, the new one. It's 29 millimeters wide. And if you include bunching up the wires in the front, you get something that's about 70 millimeters long by a height, which I didn't actually measure, which I should have, by about 30 millimeters. Let me add a block for that in the design here, and we'll go from there. So I think I got the components in a pretty well positioned manner. Things are a little tight. The battery is kind of close to a spinning weapon of death, which is, of course, of a concern, but it's not the end of the world. I think I can probably move it back this way a little bit. I just need to figure out how to adjust the strap accordingly, but that's a relatively easy thing. So the next step here is to take this A-frame, which was originally just a weapon support, now pretty much turn it into the entire structure of Micro Flash Delta. So expand out a little bit. And the other thing I'm going to do is actually decrease the width of these pieces here. Now, what I discovered back at the last Motor City Massacre is, well, the egg beater spinners that are there, and probably presumably a vertical spinner, if there was one there, could punch their way through this aluminum structure pretty easily. I mean, Microflash Delta can punch through this aluminum structure very easily if he gets a hit on it. But so what I need to do is, instead of having just 2 main structure pieces, have at least 3, maybe some more thinner pieces. So if this thing gets busted up here, then it's got 2 or 3 other pieces of aluminum to hold it all together. Here comes the first moment of truth. I've got the redesigned structure sitting here. It's kind of highlighted in a lighter gray color. I can do the math and figure out what the volume is, and from there I can calculate the mass. Let's bring up our 3D printing tool extension over here for Blender. Volume is about 21 cubic centimeters. So that seems a little low. 21 times 2.7 is 56.7 grams at the moment. Assuming that is accurate, which it's usually pretty good, that's actually not too bad. I'm kind of happy with that, 56.7 grams. Now, what I would like to be able to do is use the same piece for the top and the bottom, just for reusability purposes. I can build fewer parts, have more spare parts, all that kind of stuff. Which, that's not a bad start if this is actually how it's going to be. But let's go ahead and figure out the rest of the structure. The rear plate is done. I've got 2 plates where it attaches to the rear structure, and then it's also be held in place by the wheel bumpers, which may be a not so great idea. But let's check the volume of it, and I can address things elsewhere. Because if I have extra mass, I can make it secured better onto the back of the robot. Alternatively, don't let the opponents hit the back of the robot. It's actually pretty easy in the Motor City Massacre arena. I think it's a tiny cluster. Anyway. Volume is about 28 cubic centimeters, so let's mark it down as 28 grams in my Google spreadsheet. But there is one more thing I do have to think about, and I was mentioning earlier at the very beginning that I want to add some bearings in here so the structure of the robot can take some impacts of the robot flying around, not purely rely on the motor mounts and the gearboxes and all that kind of stuff. So what I think I'm going to end up doing is bolt on an 1/8" UHMW plate that goes right here that has the bearing embedded in it. The bearing itself is about 2.6 millimeters thick, so it can fit in an 1/8" UHMW plate, and I'm going to work on that right now. So here's the bearing plate. It should be all set up, ready to go. So the bearing will pop in there. You'll bolt it up against the motor, and then I can attach it other places, and then therefore the frame should take some of the impact on the motor instead of just purely the motor taking it when the robot gets thrown up in the ceiling and smashed into the ground, as Microflash tends to do on multiple occasions. All right, that is everything I really need for the redesign. Now for hours and hours of 3D printing. The new 3D printed body is done, as you just saw right there, and the drill, it's on standby because I'm pretty sure I screwed something up somewhere with the design and 3D printing. But let's get this assembled and see if we can get Microflash Gamma, wait, M Delta now. This is too confusing. See if we can get Microflash Delta driving. So I have the motor mounts here. Here's the first screw up. It turns out that this one section of the motor mount here, which is supposed to, bolt down to the base, is lined up perfectly with this support of the aluminum piece. So what I'm gonna have to do is that in future versions of the motor mount, I'm going to modify it so that this part right here is in line with the channel. And then I'll have to put a hole here through the aluminum structure so that the bolt can go through the aluminum structure, which isn't a bad thing. But for now, just to make life easier, I'm just going to go ahead and cut this piece off the 3D printed structure and just run with it. Screw up train continues. These two holes here that were designed to hold on the side bumpers as well as attach the side structure to the actual main structure of the robot, or side arm, or whatever. They're not really lined up with the holes in the actual structure piece right here. And I think what I'm going to have to is I'm going to have to actually use these holes here in the main structure piece because of the way it is. Otherwise, other bolts and nuts and things will get in the way. So, okay, fantastic. Let's drill these out. Alright, so the basic structure is together, motors are in place, and they're pretty secure with bearings and all. Now let's get the rest of the electronics in here, see how well everything fits, and hopefully the robot can run. So anyway, we're off to a good start here with the complete redesign of Microflash Delta. There is a lot of stupid crap that I still got to deal with, and in fact that's what I'm going to do in the next episode, deal with all the stupid crap. So things like routing the wiring around, figuring out a little bit of issues back here. I don't like how the rear armor is currently attaching. There's some things like that I really want to deal with. I've been also, let me show this off. While I was assembling the robot here, I was keeping track of all the different bolt sizes I was using. So as long as I did that correctly, I know how much weight is properly in the bolts, and I can factor that into the build process to get a better estimate of how this whole new frame design is going to weigh, because that way I know how much I've got for rear armor back here as well as things like that. So anyway, until next time, once again, I'm Jason, the creator of Team Rocco Robotics. This has been the build log for Microflash Delta, my 3-pound Beetle Weight Combat Robot, who now fits into a cube the size of, what is it, a Pygmy Marmoset? That's the world's smallest monkey, in case you're wondering where that title comes from. So thank you guys all for watching, and have a great week.